In the vast expanse of human history, our journey beneath the heavens began with an innate curiosity to understand the cosmos. Ancient observers, equipped with keen instinct and acute attention to natural phenomena, cast their gaze upward, deciphering the silent language written in the stars, the moon, and the sun. Throughout millennia, observational astronomy was not merely an exercise in empirical tracking, but served as a vital interface between practical survival and the burgeoning realm of symbolic thought. At its very inception, the study of celestial movements was deeply intertwined with daily existence. The cyclical phases of the moon, the measured journey of the sun across the sky, and the periodic appearance of prominent stars offered a framework to manage agricultural endeavors, seasonal migrations, and communal rituals. As early humans witnessed the reliable rebirth of the moon and the transformative power of seasonal changes, they began to interpret these celestial rhythms as a divine script, a code that connected earthbound life with the unfathomable cosmos. This nascent connection paved the way for an evolving discipline that would eventually be recognized as astrology. Observers in prehistoric communities intuitively recognized that natural cycles governed both temporal patterns and the spiritual order of life. The meticulous study of these cycles provided the practical basis for timekeeping and cultivated a rich tapestry of symbolic narratives that would persist through centuries. Our exploration will unravel how these early celestial observations not only ensured survival but also seeded a complex system of interpretation, where each planetary cycle and celestial event was embedded with profound symbolic meaning. This narrative invites us to scrutinize the scientific underpinnings of these observations and to appreciate the sophisticated interplay between empirical evidence and mythological constructs, forming the rudimentary foundations of astrological thought. Thus, the ancient night sky both captivated and guided humanity. Prehistoric communities developed a systematic approach to celestial observation that was as much scientific as it was instinctual. Daily patterns in the movement of the sun provided not only a measure of time, but also crucial insights into seasonal variations that dictated migration paths and agricultural cycles. The trajectories of stars across the vault of the night, noted for their consistent appearance and decline, were meticulously recorded by early observers through memory and symbolic representation. Detailed observation of lunar phases served as an accurate timekeeper, instrumental in synchronizing community activities and rituals intrinsic to survival strategies. These early observers engaged in empirical tracking that, over generations, honed an understanding of astronomical cycles. The regularity with which phenomena such as the solstices and equinoxes occurred allowed ancient peoples to develop rudimentary calendars, devices that transformed the chaotic passage of time into an organized sequence of events aligning with natural laws. The repeated emergence of specific constellations heralded critical periods, including the onset of rainy seasons or the retreat of frost, thereby influencing decisions on when to sow seeds or prepare for harvest. In these observations, technical precision met experiential insight. Prehistoric astronomers combined careful measurement with oral traditions to codify a calendar system based on celestial mechanics. The integration of observational data with ritualized practices was not arbitrary. It was formed by a deep intuitive understanding of natural order, merging practical necessity with the symbolic significance attributed to the cosmos. Their systematic recording of star positions and lunar cycles laid the groundwork for more refined astronomical tracking in later civilizations. Modern analyses have revealed that many of the observational methods used by prehistoric societies exhibit a level of sophistication comparable to early scientific methodologies, including seasonal forecasting based on celestial indicators and the practical application of astronomical observations in everyday life. This intricate dance between empirical observation and symbolic interpretation exemplifies the emergence of scientific thought encapsulated within the origins of astrological practice, setting a precedent for the evolution of astronomy and philosophy. Modern investigations using simulations and modeling reinforce these distinctions, confirming that myth and observation were inseparable. This fusion of symbolic significance and empirical data laid a critical foundation for the evolution of astrology and early scientific inquiry. The utilization of celestial cycles as empirical tools in timekeeping and agriculture marked one of humanity's earliest triumphs in scientific application. The predictable lunar phases, especially the alternating crescents and full bulbs of the moon, formed a natural calendar that intimately guided the scheduling of agricultural operations. Early cultivators observed that the waxing and waning of the moon could be correlated with moisture levels and tidal influences, factors that indirectly signaled optimal planting times and harvest periods. The methodical alignment of community activities with lunar cycles optimized the efficient use of labor and resources in a world dictated by seasonal uncertainty. In many regions, archaic societies integrated their observations of the moon alongside solar and stellar patterns to construct comprehensive calendrical systems. The solstices and equinoxes, marked by distinctive shadows and temperature shifts, were instrumental in determining the lengths of growing seasons. This periodical adjustment allowed for the fine-tuning of agricultural practices, where timing was paramount to securing food supplies. Advanced statistical observations, even in rudimentary forms, enabled ancient farmers to predict climatic events, an approach that was rooted in an evolving understanding of the cyclical nature of time itself. Furthermore, the interrelation between these astronomical cycles and ecological phenomena was rigorously noted. Detailed correlations were drawn linking celestial events to the patterns of river floods, the migration of insects, and other natural indicators. This practical knowledge, empirically derived and socially transmitted, served as an essential component of community survival, as well as laying the empirical groundwork for later formalizations in calendrical science. The nuanced understanding of the interplay of lunar, solar, and stellar events fostered an early scientific methodology, an observationally driven, fact-based approach that seamlessly combined statistics with natural philosophy, presaging modern scientific practices. The cumulative empirical experience refined observational techniques that have a legacy in contemporary precision agriculture, evidencing that even ancient practices carried complex, data-driven insights into the natural world. These early methodologies were quantitatively sophisticated, bridging observational astronomy and statistics. Their integration of celestial patterns with agricultural timing underscores an empirical acumen that researchers continue to admire for its precision and remarkable relevance in agronomic science. Beyond the empirical applications of celestial observation lay a richer terrain of symbolic and spiritual interpretation. Prehistoric cultures, while keenly observing the heavens for practical purposes, simultaneously imbued these celestial phenomena with attributes of mystery and divinity. Each observed pattern, the meticulous course of the moon, the predictable paths of prominent stars, and the majestic procession of the planets, became interwoven into the religious and mythological tapestry of early societies. These observations were not viewed in isolation, but were integrated with cosmological myths that sought to explain natural forces, human destiny, and the cycles of life and death. An elevated sophistication characterized these symbolic attributions, where the regularity of celestial motions was seen as evidence of an underlying cosmic order. Early spiritual frameworks posited that deities and ancestral spirits were represented in the constellations, instilling natural phenomena with layers of meaning beyond mere survival utility. The attribution of fertility, transformation, or even impending doom to specific stars or planetary alignments reflected a sophisticated system of signs that demanded both empirical observation and deep metaphysical reflection. Furthermore, ritualistic practices often incorporated astronomical events as central elements in ceremonies, binding personal fate to the perceived will of celestial forces. The complexity of these interpretations is evident in the fact that many early cosmologies were built upon a dual foundation, one that acknowledged observable physical phenomena and another that honored the symbolic resonance of these events. Modern experts analyze the correlation between cyclical celestial events and ritual calendars, revealing that the structure of numerous ancient narratives mirrors statistically significant astronomical cycles. This interdisciplinary synthesis of data and myth highlights an early form of analytic thought, a blend of qualitative symbolism and quantitative observation that remains influential in contemporary astrological research. In many respects, the symbolic interpretations of the ancient skies foreshadowed later philosophical discourses on fate, free will, and determinism. Scholars today regard these early systems as an amalgamation of art, science, and spirituality, a testament to humanity's enduring quest to attribute meaning to the natural world. The subtle interplay between empirical observation and myth underscores a profound human tendency to search for deeper connections within the universe, laying the groundwork for the codified astrological traditions we study today. Modern investigations using simulations and modeling reinforce these distinctions, confirming that myth and observation were inseparable. This fusion of symbolic significance and empirical data laid a critical foundation for the evolution of astrology and early scientific inquiry. Archaeological records provide a tangible portal into the sophisticated astronomical practices of prehistoric societies. Excavations at key sites, such as Göbekli Tepe in modern-day Turkey and the Nebra sky disk in Germany, reveal that early humans not only observed the heavens but also created elaborate representations of celestial phenomena. The architectural alignment of Göbekli Tepe, with its intricately arranged megaliths, suggests that its constructors designed the space to mirror astronomical events. Similarly, the Nebra sky disk, with its precise depiction of the sun, moon, and stars, demonstrates an advanced understanding of cosmic cycles. These artifacts serve as concrete evidence that prehistoric societies engaged in systematic observation and recording of celestial bodies. Meticulous measurements inscribed on these artifacts indicate that the creators possessed quantitative skills adept at aligning physical structures with celestial points. Detailed analyses have compared the angular positions and spatial alignments evidenced at these sites with modern astronomical data, revealing a remarkable congruence. Such precision indicates that the observations were not purely intuitive but were underpinned by rigorous, empirically derived methods. Modern computational techniques have allowed researchers to reconstruct the ancient skies, confirming that these artifacts were designed with a deliberate awareness of precessional changes and stellar configurations. The synthesis of archaeological evidence with advanced statistical astronomy has transformed our understanding of prehistoric skywatching. In scrutinizing the materials, inscriptions, and spatial layouts, researchers have delineated a clear methodology that combines observational data, geometry, and early forms of trigonometry. This confluence of practical measurements and sophisticated symbolism illustrates a dual commitment to both utilitarian purposes and spiritual representations. Furthermore, the artifacts illuminate how early observations served as both functional tools and as cultural narratives. These findings have been corroborated by independent studies that employ precise radiometric dating and astronomical modeling, establishing a secure chronology and contextual framework. The robust alignment between these ancient records and contemporary astronomical parameters underscores the enduring legacy of early observational practices, offering a profound testament to the empirical ingenuity of our ancestors. Recent interdisciplinary studies combining archaeology, astronomy, and advanced imaging techniques have further validated the precision of these ancient constructions. Researchers have uncovered evidence of deliberate astronomical alignments and mathematically sophisticated design choices, suggesting that these societies employed early forms of geomathematics. This convergence of hard data and cultural expression provides a compelling argument for the advanced observational acumen present in prehistory, resonating with modern scientific principles. These findings continue to reshape our perspectives. Over successive millennia, the empirical and symbolic frameworks established in prehistoric observations evolved into increasingly elaborate systems of astrological interpretation. Early celestial recordings, initially designed to track seasonal changes in agricultural cycles, gradually became codified into complex models that linked cosmic phenomena with human affairs. As civilizations expanded, notably in Mesopotamia and Egypt, the pragmatic observations of early societies were augmented by ritual, numerology, and emerging mathematical systems, culminating in the creation of precise ephemerides and charts delineating planetary movements. This evolution was marked by the assimilation of empirical data with interpretive traditions. Early astronomers adopted methods that involved intricate geometrical modeling and statistical analysis, approaches that refined the accuracy of planetary forecasts. The integration of observational precision with mythological syntax allowed these systems to not only predict seasonal changes but also to offer insights into personal destiny and sociopolitical trends. Scholarly investigations have shown that the transition from prehistoric skywatching to structured astrological systems was a gradual process, characterized by the accumulation of quantitative data and the sophisticated use of symbolic language. Moreover, the burgeoning field of astrological science began to encompass advanced techniques such as the calculation of planetary conjunctions, retrograde cycles, and the subtle influences of celestial mechanics. Numerical records, both in the form of tablet inscriptions and later astronomical manuscripts, reveal an increasing reliance on mathematical concepts, including early versions of algebra and geometry. The synthesis of these empirical and symbolic approaches laid the groundwork for a disciplinary framework that continues to influence modern astrological practice. The evolution of these systems reflects a dynamic interplay between human observation, statistical analysis, and the timeless allure of cosmic mystery. Subsequent scholarly work has revealed that these evolving systems incorporated increasingly rigorous mathematical frameworks and astronomical techniques. Detailed inscriptions and computational records illustrate the progressive refinement in observing planetary trajectories. This development marks a pivotal transition from observational folklore to a structured, quantifiable discipline, encapsulating centuries of accumulated empirical knowledge and interpretive sophistication that still resonate in contemporary astrological practice. These advancements reflect a cumulative legacy of analytical brilliance that has continuously shaped the trajectory of astrological science profoundly. In concluding this detailed exploration of astrophysical origins, one observes that the ancient practice of skywatching was much more than a rudimentary survival mechanism. The evolution from prehistoric observations to the intricate astrological systems of subsequent civilizations exemplifies an enduring legacy of empirical precision and symbolic depth. This narrative reveals that early societies, through meticulous astronomical observation, not only established the practical foundations of calendrical science and agricultural planning, but also wove these patterns into the mythological fabric that continues to influence modern philosophical and scientific thought. The convergence of empirical data and mythological symbolism in these early practices has far-reaching implications. Today, sophisticated statistical models and advanced astronomical simulations are employed to reassess ancient artifacts and records. Researchers now validate the numerical and analytical techniques embedded in prehistoric observations, confirming that the ancient observers possessed an unexpectedly rigorous understanding of cosmic cycles. This continuity from past to present illustrates a seamless integration of observational science with the symbolic narratives that define human culture. Moreover, the multifaceted legacy of early astrological practices can be observed in contemporary epistemological debates that bridge the gap between the rational and the mystical. In modern astrological research, the echo of prehistoric methodologies resounds through detailed analyses of celestial mechanics and their perceived correlations with terrestrial events. This synthesis underscores a timeless human inclination to decipher the cosmos, merging quantitative rigor with interpretive insight. As the narrative draws to a close, it becomes evident that the insights gleaned from our ancestors provide invaluable context for understanding modern scientific paradigms. The ancient legacy of skywatching serves as a reminder that the quest for cosmic understanding is as much an art as it is a disciplined scientific endeavor, one that continues to inspire and challenge contemporary interpretations of the universe. Ultimately, these temporal and spatial records not only testify to the ingenuity of our early predecessors but also illuminate the interconnected nature of knowledge across disciplines. Their legacy is a bridge connecting the empirical rigor of science with the evocative power of myth, a synthesis that enriches our ongoing exploration of cosmic truth, inspiring future generations perpetually.